Hi friends, this is Dr. Gunamani Jana, and in this video we'll be dealing with the 8085 microprocessor. Actually, our aim is to go for this 8086 because uh, for understanding the 8086, we should have some knowledge about this 8085 microprocessor. So let us have an idea about what is this microprocessor and microcontroller, what is the syllabus for this thing. In 8086 microprocessor architecture and programming, we'll be covering the register organizations of 8086, architecture of 8086, and the syllabus you can see, check it in your details. Now, coming to the introduction of microprocessor, we know that microprocessor is a programmable electronic chips that has computing and decision making capability. It is just similar to the central processing unit. So I can say it is a small or mini CPU, central processing unit. So if a system having this type of microprocessor, we say it is a microprocessor based system and having the limited number of resources called the microcomputers. Nowadays, microprocessors can be seen almost in all type of electronic devices. Like we can go for the mobile phones, what you are using, the printers, washing machine, everywhere we find some microprocessor is attached. Right? Now, these microprocessors are also used in advanced applications like, see, radars are there, satellites are there, flights are there. So, due to this rapid advancement in electronic industry and large-scale integration of devices, result in a significant cost reduction and increased applications of microprocessor and their derivatives. Now, we can classify the microprocessor based on the size of the data bus. Suppose the data bus is 4 bit, we say it is a 4-bit microprocessor. Similarly, 8-bit microprocessor, 16-bit microprocessor, and 32-bit microprocessors. And based on the application also we can divide. So we can call one microprocessor a general purpose microprocessor. For example, 8085, Intel Pentium, all the things are there. So it is used in general computing systems and can be used by programmer for any applications. Similarly, we are going for a microcontroller, microprocessor with built-in memory and ports. Together we can call it as a microcontroller. Understand? Example is 8051. Similarly, we are having special purpose processors. They are designed to handle special functions required for an application. For example, digital signal processors and application specific integrated circuits, ASIC. All the chips, it will be coming out of that one. So these are the different types. Then based on architectures, we can go for the reduced instruction set computer, RISC processor, or complex instruction set processor computer, that is the CISC processors. If you come for this 8085 microprocessor architecture, so this is a 8-bit processor, what I told you, and there is 40 a number of DIP, dual input pins, DIP, IC package, and it uses a 5 volt, plus 5 volt for power. And it can run at a maximum frequency of 3 megahertz, and the data bus is 8-bit, and the address bus is 16-bit. 16-bit means 2 to the 16, the 64 kilobyte of number it can. So this is the diagram of all the things. You can check it here. This is the accumulator in the central part. You can see, and these registers are there. Temporary registers are there. Flags are there. Arithmetic logic unit ALU is there. Okay. So various buses will be there. Internal data buses will be there. Address buses will be there, and control unit is timing and control will be there. Address buffer, data address buffer. So this is the interrupt control and different pins are also given to this thing. That will study in details, don't worry at this time. So while coming to this arithmetic and logic unit, as we said, it is also ALU. The ALU performs the actual numerical and logical operations such as addition, subtraction, and or logical, all the things that we can do it there. It uses data from memory and from accumulator to perform these operations. Either it takes from the memory or accumulator or from both. Then it goes for the various operations as I told you. Right. The results of these arithmetic and logical operations are stored in the accumulator again. Then coming to the number of registers, the 8085 includes 6 registers, one accumulator and one flag registers. We'll show this in the figure number 3. In addition, it has two 16-bit registers like the stack pointer and the program counter. It's clear? Now 8085, it has 6 general purpose registers to store 8-bit data, and these are B, C, D, E, H, and L. And they can be combined like B, C, D, E, and H, L. So 8-bit plus 8-bit, it will be 16-bit operations, right? The programmer can use these registers to store or copy data into the register by using data copy instructions. Now, what I told you that you can see here, you see here the accumulator here is a 8 bit here, and the flag registers 1, 2, 3, 4, 5, 6, 7, 8. Is there also you can check it there. So B 8 bit, C 8 bit. If I am using BC, then it will be 16 bit. D 8 bit, E 8 bit. So B is base, C for count. You don't worry for this, that, this. I will explain all things. Then H and L, the stack pointer, what I told you is a 16 bit, and the program counter is a 16 bit register. No, the data will be to and fro, coming and going. Address is one direction. So data bus is eight lines. That is bidirectional. This is the 16 lines unidirectional, right? So this is the register organization of 8085. Now coming to the accumulator, what you studied in the previous page, this is the accumulator, written as A, stand for the accumulator, right? So this accumulator, it is a 8-bit register, that is part of this ALU also. And this register is used to store 8-bit data and to perform arithmetic and logic operation. To store 8-bit data and perform these operations, we use this accumulator. And the result of an operation is also stored in the accumulator. So the accumulator is also identified as register A. In the initial you have seen, so this is the register A, I have written accumulator, and A stand for this accumulator A, right? Then coming to the flag registers, ALU includes 5 flip-flop. Where is the flip-flop? You can check it here. Flag registers 1, 2, 3, 4, 5, 6, 7, 8 are there. So 1, 2, 3, 4, 5. These are the middle flag registers. You can check it there, right? So fine. So they are called, the ALU includes 5 flip-flop which are set or reset. This purpose after an operation according to data conditions of the result in the accumulator and other registers. So what are they called? These five? Z for zero, CY for carry, S for side, P for parity, and AC for auxiliary carry flags. You get it now? In the central part, you are seeing 5 number of flags. 1, 2, 3, 4, 5. You see, this is the flag registers. So then they only give the status of that one. That's why I put the flag registers. The microprocessor uses these flags to test data conditions. Fine. Then we are going for the program counter. As you have seen this diagram, program counter here is a 16-bit register. This one, this is bottom ones. Okay. So program counter, it is a 16-bit register. It deals with sequencing the execution of instruction, which will come first, which will come second. So this is the sequence to be there. And this register is a memory pointer. So what is the meaning of memory pointer? It should be pointing the starting point of that instruction, right? And the microprocessor uses this register to sequence the executions, which will come first, which will come next second, which will come third. That sequence should be done. It will be done in the program counter, pointing to the next instruction. The function of the program counter is to point to the memory address from which the next byte to be fetched. Fetching of the data will be done there. So which one I am going to fetch next, that will be there in the program counter. Then stack pointer, this is also, as you have seen, it is also a 16-bit register used as a memory pointer, and it points to a memory locations in a redirect memory called stack. And the beginning of the stack is defined by loading 16-bit address in the stack pointer. Okay, you got some idea. Similarly, we are having instruction register, decoders. This instruction register, decoder, it is a 8-bit register, and that temporarily stores the current instructions of a program, because instruction, okay, so instruction registers are decoder. See, instruction registers and decoder. Uh, not saying. Okay, don't worry. Uh, Decoder can take instruction and decodes what to do. Decode means the instruction is there, but what to do, that you have to understand that one. That is the decoding, or interprets the instruction. Decoded instruction then passes to the next stage. Control unit generates signals on data bus, address bus, and control buses within the microprocessor. You carry out the instruction. What to do? You go for addition, multiplication, and which has been decoded. Typically, buses and their timing are described as follows. You see, there are different type of buses, as I told you. One is the data bus, one is the address bus, and control. Okay. So this data bus, as you see, this carries purely data in binary form between microprocessor and other external units are there, such as memory and other things. Right. So what is binary data? 0, 1, 0, 1, 1, 1. So if it is 0, then it will be 8 number of zeros. If it is say 8 number of one, so it is 0 to 255. You can put it there. Okay. So this data bus is a 8-bit, so it can carry 2 to the power 8. Okay, that is 256. So the pin use D0 to D7. I'll show you the pin diagram. There you can understand. This size of the data bus means what arithmetic can be done. If only 8 bit wide, then largest number will be 8 number of ones. 1, 1, 1. This is 255 because 2 to the power 8 minus 1. Therefore, large number have to be broken down into the chunks of 255, and this slows the microprocessor. Fine. Now, in the address bus, as you know, some latching is there. So, A0 to A7, D0 to D7, they are latched. Sometimes they can be used as address bus, and when it is there, it can be used also data bus. So now, when it is not latched, then A0 to A15, 16 number of bits are there for this address. Okay, the address bus carries addresses and is one way from microprocessor to memory. Address bus would be only from microprocessor to memory, right? And this 8085 microprocessor, it contains 16-bit address bus and are generally identified A0 to A15. Then coming to the control bus are various lines which have specific function for coordinating and controlling the microprocessor operations. The control bus carries control signals partly unidirectional in one direction and partly bidirectional. These following control and status signals are to be used by the microprocessor. This here, one is the address latch enable ALE. Okay, address latch enable is a pulse that is provided when an address appears on the AD0 to AD7 during the lower bit, and after which it becomes again 0. Okay. Then RD, that is when it is acting low, it is the read operations. Okay. So that being read from this selected IO or memory. So read from memory or from this input port. Similarly, write WR. So the write signal indicate that data is on the data bus and have to be written into the selected memory or applications. So IOM, so it is a signal that distinguish between a memory operations and it is a memory operation, or if its IO bar is 0, then it is a IO, otherwise it will be like that it will be there. Okay. Similarly, S1 and S0, these are the output. These are status signals used to specify the type of operation being performed. They are listed in the we'll see it here. Then the schematic representation of 8085 bus structures as shown will show in the next figure. Here, four things will be there: memory read, memory write, IO read, and IO write. Right. So this is the things you can see here. So A0 to A15 here, and D0 to D7 here. This is the data bus, and this is the address bus, and of course this is the control bus. And control bus is unidirectional from microprocessor to others. Right. So in this way, if you go for the 8085 pin description, it has 8-bit microprocessor manufactured with NMOS technology, and it is a 40-pin DIP dual input package, dual input pin. This is just like an integrated circuit, and it has 16-bit addressing bus and thus 2 to the power 16, that is 64 kilobyte addressing capability. It operates with 3 megahertz single phase clock. You know that quartz will be given. It will be basically 6 megahertz, and when any signal or voltage is applied on that one, it will generate 3 megahertz. That you know. Then it will operate on plus 5 volt single power supply. So this is the thing. Similarly, the logic pins also will having the address bus, the data bus, the control and status signal, power supply. Okay, and external initiator signals. All the things will be there. Now let us have a look at this 8085 microprocessor pin layout. So if you see here, this clock related things will be X2 and X1 here. You can see it. And you see VS, S is the ground and VCC is the 5 volt it is provided here. And if you see 80 here, pin number 12 to pin number 19, it is 80 to 87. And similarly, A to A15, that is 21 to 28. Okay. So it can, this, when it is not latched, it can be used as a data bus. And when I want to use address bus, this along with the right side, the A9 to A15 can be used, right? So similarly, whatever things I have given S1, S0, status, similarly read, write, and address latch enable, all things you can see. In addition to this, we are having serial input output, SOD output, SID, then reset, there it is also there. Interrupt will be there also. In the reset, we are having the first priority trap, then reset 7.5, reset 6.5, 5.5, then interrupt here interrupt acknowledgement is there. So this is the pin diagram. If time permits, you study in detail. This is not in the syllabus. It is starting from 8086, but for your knowledge, information, okay, I am telling all the things. Then, as I told you that A8 to A15, This is the output and this is the three state. As most significant 8-bit of memory addresses and the 8-bit of the IO addresses. And these lines enter into tri-state high impedance state during the hold and halt modes. Right. Similarly, a D0 to A7, this can be used as address bus and data bus. So this is the lower significant bit memory. The higher one, these are A8 to 15, and the lower one is A0 to A7 or AD0 to D7. Okay. So during third and fourth clock cycle, these lines enter into tri-state high impedance and okay, right. Similarly, we are having the ALE. We are talking about the pins. That is the address class enabled read and write. IOM S1 S2 is just data signal, power supply, clock frequency, VCC plus byport. VS is the ground interface. X1 and X2, a crystal having frequency of 6 megahertz, and it is connected at these two pins clock, and it is generated at 3 megahertz, right? Then we are having the different addressing mode in instructions. One is the immediate addressing mode, memory direct addressing mode, register direct addressing mode, and indirect addressing mode. And final one, the implicit addressing mode. These things we'll cover in the next video. If you like this video and you understand or you have any query and comments, so you can send a message to me so that I will try to attend it. Thank you. Thank you for this attending this video.